What if an engine explodes mid-flight? What if a hydraulic line gets cut by enemy fire? What if half a wing suddenly disappears? For most aircraft, any one of those scenarios is the end. You eject and hope for the best. But there are a handful of fighter jets in history, and a few flying right now, that have survived exactly these situations. Not in simulations, not in movies, in real combat, in real emergencies, with real pilots who came home alive. Today we're talking about the fighter jets that experts consider almost impossible to kill. The aircraft specifically engineered or proven through brutal real-world testing to survive failures that by every law of physics should have been unsurvivable. And trust me, some of these stories are going to make your jaw drop. Let's start with the most legendary one. 1983, Israeli airborne exercise over the Negev desert. An F-15D Eagle and an A-4 Skyhawk collide mid-air. The collision is violent and sudden, and when the chaos settles, something completely insane becomes clear. The F-15 has lost its entire right wing, not damaged, not partially there, gone. By every principle of aerodynamics, that aircraft should have tumbled out of the sky in seconds. A jet with one wing has no business flying. But here's what actually happened. Pilot Zivi Nedivi and his navigator Yehoar Gal, both of them still in that jet, somehow kept the aircraft in the air. The two massive Pratt & Whitney F-100 engines were generating so much thrust that the jet was essentially flying on engine power alone, using the remaining wing and raw thrust to maintain enough control to stay airborne. Nedivi declared an emergency, came in at nearly twice the normal landing speed, and put that aircraft down on the runway in one piece. He only realized the right wing was completely gone after he climbed out of the cockpit and looked at his own plane. He later said that if he had known, he almost certainly would have ejected. That story tells you everything about the F-15 Eagle. McDonnell Douglas engineered this aircraft with a level of structural redundancy that borders on obsessive. It runs two completely independent hydraulic systems. If one fails, the other takes over instantly, with no pilot input required. The airframe was built to handle stress loads far beyond what it would ever encounter in normal combat. And those engines are powerful enough to compensate for damage that would make any other aircraft uncontrollable. In its entire operational history, the F-15 has never lost an air-to-air engagement. But it's moments like a two-man crew landing without a wing that show you the engineering behind that record. If you're enjoying this so far, drop a like on the video. It helps the channel more than you know. And if you're new here, subscribe so you don't miss what's coming next. Now let's talk about the aircraft that might be the most battle-hardened jet ever built, the A-10 Thunderbolt II. Everyone calls it the Warthog, and honestly, the name fits perfectly. This plane was not designed to be elegant. It was designed to absorb punishment and keep flying. The pilot sits inside a literal titanium bathtub, 200 pounds of armored titanium surrounding the cockpit, built to withstand direct hits from cannon fire and shell fragments. The two engines are mounted far apart and positioned high on the fuselage, specifically to ensure that damage to one engine cannot take out the other. The fuel tanks are self-sealing, and the flight controls have a full manual reversion mode, a completely mechanical backup that operates through cables and physical linkages with zero reliance on hydraulics whatsoever. The engineering philosophy behind the A-10 was brutally simple. Assume the aircraft is going to get hit. Build it so it flies anyway. And then there's the real-world proof. April 7th, 2003, Operation Iraqi Freedom. Captain Kim Campbell is flying her A-10 over Baghdad when a surface-to-air missile tears through her aircraft, hitting the right horizontal stabilizer and severing the hydraulic lines. The damage is severe. She loses all hydraulic pressure to the flight control surfaces instantly. In almost any other jet, that is an immediate ejection situation. No hydraulics means no control surfaces. No control surfaces means no airplane. Kim Campbell did not eject. She activated manual reversion mode, switching to the purely mechanical backup, a system of cranks, pulleys and cables that physically connects the pilot's inputs to the control surfaces with no hydraulics involved. And she flew that A-10 for about an hour, roughly 300 miles through hostile territory, all the way back to base in Kuwait. And she landed it safely. She was awarded the Distinguished Flying Cross for that mission. The A-10 has a long documented history of returning from combat with catastrophic damage. Engines destroyed, tail sections partially missing, hundreds of holes through the airframe. It keeps flying. That is not luck. That is engineering. What do you think? Is there any modern jet that could do what the A-10 does in close air support? Tell me in the comments. Let's keep going. The A-10 Super Hornet. This aircraft operates in one of the most demanding environments on the planet. Aircraft carrier operations, launching off a catapult, landing on a moving deck in the middle of the ocean at night in bad weather. The margin for error is essentially zero. To survive that environment, the Super Hornet uses a quadruplex digital fly-by-wire flight control system. 4 completely independent computers managing the control surfaces simultaneously. If one fails, the other 3 carry on without any interruption. If 2 fail, the remaining pair holds it together. Beyond that, the system can actually detect battle damage mid-flight and automatically reconfigure how it uses the remaining control surfaces to compensate. The Super Hornet can lose an engine mid-mission, absorb significant damage, and still get the pilot back to the carrier. It's an aircraft built on the understanding that carrier aviation is inherently unforgiving, and that redundancy isn't a luxury feature, it's survival. And then there's the F-22 Raptor, the most advanced air superiority fighter ever built. The F-22 runs a triplex fly-by-wire system. 3 independent flight control computers running simultaneously, combined with thrust vectoring nozzles that give the pilot control authority, even in situations where conventional control surfaces would be useless. Multiple redundant hydraulic circuits run throughout the airframe, and dual redundant engine control systems manage each of the 2 Pratt & Whitney F-119 engines independently. The F-22 was conceived to operate in the most contested and dangerous airspace imaginable, take hits, and still complete the mission. Its entire architecture is built around the assumption that something will go wrong, and that the jet needs to handle it before the pilot even realizes what happened. 4 jets, 4 completely different approaches to the same problem, but one idea connecting all of them. They were built by engineers who assumed failure was inevitable. The question was never if something goes wrong. The question was always, when it does, what happens next? Every backup hydraulic system, every redundant computer, every pound of titanium armor, every cable and pulley in a manual reversion mode, all of it exists because someone in a design room asked that question and then built the answer directly into the aircraft. That is the difference between a crash statistic and a pilot who walks home. Zivi Nedivi and Yehoar Gal landing without a wing. Kim Campbell bringing her A-10 back from Baghdad on nothing but cranks and cables. The Super Hornet catching an arresting wire on a pitching carrier deck after absorbing battle damage. These aren't just remarkable aviation stories. They are proof that when engineering is done right, when redundancy is layered into every single system, humans can survive things that have absolutely no right to be survivable. And that, honestly, is one of the most extraordinary things about modern aviation. These machines were built not just to fly, they were built to refuse to die. If this video impressed you, hit that like button. It makes a real difference for the channel. Subscribe if you haven't yet, and ring the notification bell so you're the first to see the next video. We have more stories like this coming, and they only get wilder. See you in the next one.